domains of some common functions. On this problem, we will find the domains of some common functions. Three things we have here. The first, if we have a rational function, the denominator is not equal to 0. For the radical function, especially for an even root, I should say only for an even root, uh, everything inside must be greater than or equal to 0. So inside an even root have to be greater than or equal to 0. And the argument of the log must be positive. So those are three things we need to watch out for. Right, now we go to the first part of the problem. This is a polynomial. It is defined everywhere. This is a radical function, but we have a cube root. So it's not an even root. So we're okay there. So for this problem, the domain is all real numbers. Or we will write negative infinity to infinity. Again, polynomial defined everywhere. The cube root, not an even root, also defined everywhere. Next, we have a rational function. So rational function, the denominator cannot equal to 0. So we have 2x minus 5 not equal to 0. Subtract, add 5 on both sides. We have 2x not equal to 5, or x not equal to 5 over 2. Right. But if we write that in interval notation, we can have anything on the left of 5 half and on the right of 5 half, but not at 5 half. So we can write negative infinity to 5 half, and then union with 5 half to positive infinity. Right, so that is the rational function. Next we have the square root. This is a square root, so it is an even root. We need to have inside even root greater than or equal to 0. So we have 4 minus 2x greater than or equal to 0. Subtract 4 on both sides. We have negative 2x greater than or equal to 0. Negative 4. Next, we will divide by negative 2 on both sides. If we divide by a negative number, remember, every time we divide by a negative number, the inequality must be reversed. So that gives us x less than or equal to 2. So if we draw that on the number line, let's say 2 is here, it's going to be less than or equal to 2. Or interval notation, negative infinity to 2. Right, next. Next we have the combination of a polynomial. For this one, it's all real numbers defined everywhere. So for that, we have negative infinity to infinity. So we only need to worry about what we have here. Is this at the denominator, and at the same time we have the square root, so that two things we need to worry about here. First, the denominator not equal to 0. Next, inside the square root have to be greater than or equal to 0. So those are two things we need to, both of them have to be true. So for the square root, we square both sides. We have x minus 3, 0 squared is still 0. We square both sides. That's why we have. So x not equal to 3. X not equal to 3 if we add 3 on both sides. Here, if we add 3 on both sides, x greater than or equal to 3. Since we have to have greater than 3, I mean not equal to 3 and greater than or equal to 3, it is greater than, but it cannot equal to. So both of them combined, we have just x greater than 3. It cannot be equal. On the number line, it is greater than 3. Next, we have another rational function. The denominator have to be greater than or equal to 0. So we subtract 1 on both sides. I'm sorry, it's not equal to. Right, denominator not equal to 0. So subtract 1 on both sides. X squared is not equal to negative 1. Now we take the square root on both sides. So x is not equal to, right? We take the square root on both sides. Take the square root on both sides. Remember, every time we do that, there's a plus or minus. So we have x not equal to plus or minus square root of negative 1 is imaginary. Since the domain we defined only for real numbers, this is not equal to imaginary numbers. So what it means is it works for all real numbers. So the domain is all real numbers. Next we have a natural log of x plus 3. For the natural log or log of any base, in sign of the log or the argument of the log must be positive. So we only have x plus 3 greater than 0. Subtract 3 on both sides. X greater than negative 3. And so it is greater than negative 3, not equal to. And that's what we have. So these are some examples about the domains of some common function.